In chapter 2, the goal is organizing data and summarizing data. So we're going to start taking our data and organizing it in a useful way for us. So again, if you'll remember, the overarching theme in chapter 1 was collecting data. Now in chapter 2, we have the data collected, but we need to organize it. So we need to take our raw data and we need to organize that. The way we organize our data depends on whether, first of all, is it qualitative data or is it quantitative data? And if it's quantitative data, is it discrete data or is it continuous data? All of that has an effect on how we go about handling the particular data. Well, in section 2.1, we're going to focus on qualitative data. So we have some definitions here to start with. First definition, a frequency distribution lists each category of data and the number of occurrences for each category of data. So again, remember, we are dealing with qualitative data. And with qualitative data, remember, the most that we can really do is categorize individuals by the different possible values or the different possible qualities. So again, we call this frequency distribution. Basically, a frequency distribution is a count. We count how many of each type of item occurs in our data. A relative frequency is the proportion or the percentage of observations within a category and is found by the formula relative frequency equals the frequency divided by the sum of all the frequencies. So we're going to take the count, the number of individuals, and we're going to divide that by the total number of individuals in our set of data. A relative frequency distribution lists each category of data together with the relative frequency. So we have an example, blood type. A phlebotomist draws the blood of a random sample of 50 patients and determines their blood types as shown. So we have the blood types of a random sample of 50 individuals. Question A, we're supposed to construct a frequency distribution. Question B, we're supposed to construct a relative frequency distribution. Question C, according to the data, which blood type is most common? And question D, according to the data, which blood type is the least common? So we're going to organize this qualitative data into a frequency distribution and into a relative frequency distribution. So first of all, if I look at my data, what are the different possible outcomes that could have occurred? Well, a person could have like a blood type A, a person could have a blood type B, a person could have a blood type AB, or a person could have a blood type O. Those are the possible outcomes. There's only 4 blood types. So what I'm going to do is I'm going to list my different categories. So here I have blood type. Again, these are my categories. And I'm going to just list what those were. So we had A, we had B, we had AB, and we had O. And then I'm going to find the frequency. So again, all frequencies means is the count. In our sample of 50 individuals, how many had a blood type? So I just have to go through and count. So if I go down this first column, well, there weren't any A's in that column. If I go down the second column, there's 1, 2, 3. Third column, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there were 18 individuals who had A blood. So that's all there is to it. You just count. You got to do the same thing for B, A, B, and O. So for B, there's 1, 2, 3, 4, 5, 6, and it looks like that's it. Only 6 individuals had blood type B. AB, 1, 2, 3, 4. Only 4 individuals had AB blood type. And so O's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I have 22 individuals who had O blood. Those are the frequencies. Now, as a partial check, if I add these up, that should add up to the number of data values that I have. So in this case, if I add up 18, 6, 4, and 22, that does add up to 50. If that doesn't add up to 50, then I've goofed up in my counts, and I would need to correct that. So relative frequencies. Relative frequencies means I'm going to basically just change these into proportions. I would say percentages, except usually we don't actually write them as percentages. We write them as the decimal form of a percent. So for example, to find the relative frequency of A blood, I'm just going to take the frequency 18 and I'm going to divide by the total number of individuals in my sample, which was 50, and 18 divided by 50 is 0.36. So the relative frequency is 0.36 or 36%. Now again, in statistics, we don't usually use percents, we just say 0.36 is the relative frequency. In the same way, if I take 6 divided by 50, that's going to be 0.12. So the relative frequency of B blood type is 0.12 or 12%. For AB, 4 divided by 50 is 0.08 or 8%. And for O, 22 divided by 50 is going to be 0.44 or 44%. If I add up the relative frequencies should add up to 1. So again, that's a partial way of checking whether or not you've done this correctly. If that doesn't add up to 1, something's wrong. The only real reason why it maybe shouldn't add up to 1 would be rounding. In this case, we were dividing by 50, so it all divides out nice and neatly. But if we had to round the relative frequencies, then we might add up to 0.999 or 1.001 instead of 1 exactly because of the rounding. Now again, just because this adds up to 1 doesn't guarantee these are right, but if they don't add up to 1, they pretty much guarantees they're not right. And the same here. If this didn't add up to 50, then that would tell me something's wrong. If they do add up to 50, that doesn't guarantee that I didn't make a mistake, but it probably wouldn't. So for part A, constructing the frequency distribution, this is the frequency distribution, the blood types along with the counts, the frequencies. For part B, the blood types along with the relative frequencies, that's the relative frequency distribution. So according to the data, which blood type's the most common? Well, based on our sample, in our sample, O blood occurred the most. So based on our sample, it would appear that O blood is the more common blood type. According to the data, which blood type is the least common? Well, in our sample, AB was only there 8% of the time, so it would appear that AB is the least common blood. Now, along with organizing our data, again, we're talking about qualitative data right now. In addition to organizing our data into these tables, again, called frequency or relative frequency distributions, Oftentimes, we will want to display our data graphically. So there are some different types of graphs that work well with qualitative data. A bar graph is constructed by labeling each category of data on either the horizontal or vertical axis, and either the frequency or relative frequency of the category on the other axis. Rectangles of equal width are drawn for each category. The height of each rectangle represents the category's frequency or relative frequency. So, an example. Use the blood type data from the previous example to create a frequency bar graph and a relative frequency bar graph. So I've already set up a grid here. So what I have in my grid along the horizontal axis, I've listed the different blood types, A, AB, B, and O. I've done that for both this grid and for this grid. And then for this graph, the vertical grid I have as the frequency, and for this graph, I have the vertical grid as the relative frequency. So if we want to create a frequency bar graph, then we're going to use the frequencies for the vertical axis. If we want to create a relative frequency bar graph, then we're going to use the relative frequencies on the vertical axis. So otherwise, all I have to do is draw bars of the appropriate height. So at the moment, I'm looking at my frequency data. Now, A had a frequency of 18. So 18 would be maybe about right here on my grid. And so all I'm going to do is draw a bar that has a height of 18. And so there we have a bar for A blood. AB, the frequency was 4. So 4 is going to be around in here, and so my bar is going to be about there. B had a frequency of 6, so 6 is going to be around here, so I'm going to have my bar there. And O had a frequency of 22, so 22 would maybe be around here, and so my bar is going to be a height of 22. So this is my frequency bar graph. For relative frequency, we do the same basic thing. The relative frequency for A was 0.36. So 0.3 is here, 0.36 would be somewhere around in here. So I just draw my bar at a height of 0.36. AB, the relative frequency was 0.08, which would be around in here. So I draw my bar that height. B, the relative frequency was 0.12, which would be around here. So I'm going to draw my bar that height. And O, the relative frequency was 0.44. So that's going to be around in here. And I draw my bar that height. So here I have my relative frequency bar graph. I do want to point out that you can use StatCrunch to draw bar graphs. You can do that depending on whether or not you have raw data or if you have data that's already been organized in a frequency distribution or a relative frequency distribution. So I'm going to show you how to do this next in StatCrunch. So I have these 50 values here that are the same data that was in the table in my problem that we drew the bar graph for. So my purpose is I can use StatCrunch instead of having to go through and count how many O's, how many A's, how many AB's, and so on. I can let StatCrunch do that for me, and I can create the bar graph. So again, I've given you on your handout, I've given you the basic steps for being able to create a frequency and relative frequency distribution, and also a frequency or relative frequency bar graph. So let's do both of those on StatCrunch here. So for this blood type data, I want to create a frequency and relative frequency table. So to do that, The first thing that we have to do is we have to have the data in StatCrunch. So in this case, I opened the data in StatCrunch, so it's already there for me. But if it wasn't, I would have to enter the data into StatCrunch. Once I have the data in StatCrunch, then if I want to create a frequency distribution, I'm going to do this. I'm going to go to Stat, which is almost always where we're going to go. We're almost always either going to go to Stat or to Graph, one of those two. So if I go to Stat and I'm wanting to make a frequency and relative frequency distribution table, so I'm going to go to Table. Now, when I point at Table, if you look at what comes up, I have three options here: frequency, contingency, and outcome. I'm going to select frequency because I want to create a frequency table. Now, when this happens, I get this window that you can see. And what I have to tell StatCrunch next is which column in this database has the data that I'm wanting to find the frequency distribution of. Well, in this case, there's only one column that has any data in it, and that is this column called blood type. So I have to select blood type. And so notice when I select that, it puts it over here. That is the data that I'm going to find the distribution for. Now, by default, this option here, frequency, and the option relative frequency are selected here. There are other kinds of tables that I could do as well, but frequency and relative frequency are selected there by default. Can you see that they're a little darker gray? If not, then you can select it and drag over, and now it's in blue, right? So clearly they're selected now. And so I'm going to say compute. When I say compute, you can see here I have the blood types A, B, B, and O, and my frequencies are 18, 4, 6, and 22. Those are the same frequencies we obtained by hand. And my relative frequencies are 0.36, 0.08, 0.12, and 0.44. So again, StatCrunch will do this for me relatively quickly. I don't have to bother with counting. It reduces my likelihood of making an error because I could miscount, and it does the relative frequencies much more quickly for me as well. We can also use StatCrunch to create a bar graph. So if I want to create a bar graph, then I'm going to go to Graph up here. So when I point at Graph, I get a whole bunch of different kinds of graphs that we could create. Now, statistics is a relatively young science. And so as a result, terminology in statistics is still evolving. So if you look at one resource, maybe one term will be used. And if you look at a different resource, a different term will be used to mean the same thing. We're going to see that throughout this course. So I said we're going to make a bar graph. Well, StatCrunch calls it a bar plot instead of a bar graph. So I'm going to point at bar plot because I want to make a bar graph or a bar chart. And then I have to tell StatCrunch, do I have data or do I have summary information? So let me explain that just for a second. So what I actually have in this case is raw data. I have the 50 different blood types that were found in the sample. If I had summary information, then that would be like the frequency distribution that I have here. So it would be saying, like in one column, that there's A is the blood type, and in the next column, it would say 18 is the frequency, and AB is the blood type, and 4 is the frequency, and so on. So that's the difference between do you have data or do you have summary information. So again, I'm back at graph and bar plot. In this case, we have data, not summary information. Like I did with the table, I have to select the column that has the data that I'm interested in. So that's the blood type column. And I have to tell StatCrunch what type of bar graph I want to find. Do I want a frequency bar graph or do I want a relative frequency bar graph? Or I could do these other options as well. We're only going to do frequency or relative frequency. Well, for now, I want to do frequency. So I'm going to highlight that and I'm going to say compute. Before I say compute, I do want to point out one other item here on this window that I would recommend you choose. And that is this right here. Put a check mark where it says value above. So when I say compute, it will put the frequency above the bar. If I hadn't checked that, then it would not put the frequency above the bar. So this is, again, the A blood type. There were 18 of those. AB, there were 4 of those, and so on. So this is a frequency bar graph. Now, if I didn't put that, if I had not checked this and I recompute, then it just doesn't have the value up there. But if I point my cursor at the bar, this bar right here, notice, is saying frequency 18 blood type A. So that's saying what the frequency is. If I point here, frequency 4 blood type AB. So AB occurred 4 times, and the same, B occurred 6 times, O occurred 44 times. If I want a relative frequency bar graph instead of a frequency bar graph, I'll just go ahead and do this over again. Select blood type, but this time I'm going to choose relative frequency and say compute. Well, if you look at the graph, this graph looks pretty much the same as the previous graph. Yes, but the only difference is I'm looking at the relative frequencies here instead of the frequencies. So if I point at this bar, now it gives me the relative frequency is 0.36 for A and 0.08 for AB, and so on. Now, I want to show you one other thing about StatCrunch. So I'm going to close StatCrunch there, and I'm back to my MyMathLab page. Now, normally, you're probably going to be working like homework problems from here in MyMathLab rather than from in the textbook. So this is normally the kind of thing you're going to see in the homework. It's the same basic problem that we just did. It's changed up a little bit. But here's what I wanted to show you about StatCrunch. Do you see this little icon right here? Select that icon. Look at the options I get. I can open this set of data in StatCrunch, or I can open it in Excel. Now, I'm not going to generally show you how to use Excel in this class, but I will be using StatCrunch. I could also copy it to the computer's clipboard so that I could paste it somewhere else if I wanted to. So here's what happens. If I open in StatCrunch, then this opens up in StatCrunch. So now I could go in and I could create my bar graph. So I could go to graph, bar plot. I have data, select my column that has the data in it, and create a frequency bar graph. And so there's my bar graph. Now this isn't the same data, so I don't get the same exact answers. In this case, for this data, the frequency 17 for A, 3 for AB, 7 for B, and 23 for O, because it's a slightly different problem. It's a different sample. So with that said, I'm going to go back to my handout. Now, the next definition we have here is of a Pareto chart. A Pareto chart is a bar graph where the bars are put in order from tallest to shortest. So if I were to take this graph right here, and if I were to rearrange so that O was farthest to the left, and then A was the next one, and then B was the next one, and then AB was the last one, so that I had the bars in order from tallest to shortest, then that is a Pareto chart. So again, a Pareto chart is a bar graph whose bars are drawn in decreasing order of frequency or relative frequency.